Our next session here, we're going to be talking about foundations of data modeling for MongoDB. I'm going to pass it off to Daniel, one of our senior staff developer advocates. Good luck. Oh, you don't need this one.
Thank you, Brooke. Hi, everyone. I'm Daniel Kupral. I've been at MongoDB for 11.5 years. Over that period, I had many different jobs. Currently help our strategic customers with their data models. This is the best job ever, at least for someone who's passionate about data modeling. So this presentation will be about data modeling. I divided it into 3 main sections. The first one will position data modeling in today's world. Then the core of the presentation is to walk you through a methodology in an example of how to do data modeling for MongoDB. We will follow the phase of the methodology, getting the requirements, identify the identities, the workload, identifying and modeling the relationships, and finally applying some schema design patterns. And finally, we'll have a very little section on schema validation. And the reason we'll do that is I can give you hopefully enough knowledge so you can pass a badge at the end of the presentation, one of our education badges. So let's start with data modeling in today's world. The world has changed from the 1970s. Believe it or not, this was the decade where most notable aspects of traditional relational database were defined. First, we get Edgar Codd publishing his papers on relational database and normalization. And we also get Peter Chan with his methodology in the ER diagrams. That is 1976. So modern applications changed the way we do data modeling. First, we have much larger data sets. Action like pulling all related data for a given relationship or scanning an indexed table or collection of many terabytes of data to answer a query doesn't make sense. Performance is at the heart of many applications. Either you have a ton of operation happening in parallel, or you may have many customers connected directly to the data around the world, and they're all expecting a very fast response from their UI. If you don't have a huge database, you may be in a race to develop and evolve quickly an application. A long and chunky process to update your schema gets in the way of being agile. And finally, security requirements such as GDPR have to be on your mind. You have to obviously obey to them. So this is a list of reality that applies if you're modeling from traditional relational database or NoSQL database. It's just because that's the way of the modern applications. So when targeting MongoDB, you model using the document model. The document model is JSON-like. It provides the ability to model a relationship with embedding or referencing. We always get these 2 choices. So we'll talk about that a little bit later. Cardinalities are important. First, regardless if you're using MongoDB, the concept of many in a one-to-many relationship comes short in our modern world. Is many 10, 100, or 1 million? For the document model, it has more profound impact regarding the size of the arrays if you decide to embed, for example. Data duplication. When we have data duplication, which again, we'll cover later in the presentation, the short story is that we consider that to be evil and to be detrimental to our application. When the reality is very different. When used correctly, it's a very powerful tool to get good performance. And finally, a flexible schema allows you to be agile, which is absolutely essential these days. Allow you to store polymorphic, which most data is. Square data is probably already in a relational database somewhere. What is left to store and exploit is much more complex and rich data. Data that can be coming from analytics, that can be used also by GenAI, etc. OK, so when we model from MongoDB using the document model and knowing what you know about modern application requirements, we do it a little bit differently. And this is what we're going to do in this section. We'll go over a short methodology. It's a 4-phase methodology with each phase building information into our schema. For those who keep track from the relational world, this is where conceptual, logical, and physical model would be matching those 4 phases. So as I said, I run a lot of reviews with the biggest customers of MongoDB. And when I do these design reviews, I often try to identify which type of project it is. And I use this uncomplicated binning of 5 different buckets. And I'll give you the main rule to basically model based on the bucket in which you would be. So if you have a lot of write operation, think Internet of Things, time series data, what you'll probably be striving for is having documents that are not too big. You don't want to make like insertion of very large document. You don't want to also insert many documents for one given piece of information you receive. The second bucket is about a lot of read operation. What we're going to do in this case is try to group the information so we don't do multiple read operations. So documents tend to be a little bit bigger in this case. The third one is also related to reads, but it doesn't mean that we have a lot of read operation. But they have to be fast. So think UI, API calls. And what we're going to do in this case, same thing. We're going to try to assemble the information. We're going to have maybe a little bit a larger document. But we're going to also try to pre-compute some data so we don't have to do these computation at the time we have to serve the request. My fourth bucket is tons of data. You get like different consideration. You probably have to make sometimes like hard call right at the beginning. But the most important or more thing that you're going to have to think about is archiving. And for that, there's different techniques to do it. The best one is obviously online archive in Atlas. So if you get to use Atlas, it's a fantastic feature to do that. And finally, the fifth bucket, when none of the first four apply, is about simplicity. There's a lot of projects that people choose MongoDB to to put their data in, and they don't necessarily have a lot of performance requirement. So in this case, what we're trying to do is to be agile. So we're going to try to keep the objects in memory the same way that they are in the database. Okay, so let's look at the first phase of our methodology. Our first phase would be identifying the main requirements of the project. We'll list what the system is supposed to accomplish. The theory and practice around writing software requirements obviously is pretty extensive. It's not something we're going to spend much time here. So the main thing here that we're interested in is identifying the entities for a project. However, here, I want to put the emphasis on qualifier main or strong entities. When you work with MongoDB, you should not be too concerned with other type of secondary entities. So let's use an example I call the universal use case. Most companies will try to sell products. So if you're a financial institution, you're selling loans or securities. If you're an e-commerce company, you're selling books, music, clothes. If you're a telecommunication company, you're selling service like cellular, residential, internet, security devices, etc. But you get this relationship between customer and product, and you get a little bit more detailed view of that example. You'll have orders in between your customer products, so that's what they buy. So that's our ER diagram. If we're going to implement that with a relational database, we will get something like that. The interesting thing with a relational solution in ER diagram is that ask you to basically model this problem with a relational database. You'll all come out with that exact solution because there's only one that respects the third normal form. Sure, we can do some denormalization. So when we do it with MongoDB, it's going to be a little bit different. There are a few things we may not have to care about, and we'll go over those, like the many-to-many relationship for associative arrays. So what I want to do is identify the category of entities I'm dealing with from my diagram. So the first type of entity I'm going to have is the strong or principal entities. These are the ones that I want to make query and receive object from. So we're going to get collection of those because they're like the most important actors in our system. Sometimes you may be tempted to use the parent entity while you should be really using the child. An example would be if you have a system that models auto parts and you decided to put the parts inside a car and you embed that information. Well, if your system is really dealing with parts, you have review on parts, you're selling parts, that should really be your main collection. The rest is just qualifier on your parts. Then the second type of entities that you have through an ER diagram or through a list will be lookup tables. These are lists of values. Could be something like country names, cities, etc. Usually what you're going to be doing at MongoDB is you're going to make a copy of those strings. You're going to denormalize them. You're going to copy them inside the documents. The third type of entities are the one I refer to as associative or junction table. So those are entities that basically have two foreign key reference to two other entities. The thing is, with MongoDB, we don't really need those. Here's an example with a relational database. I'm going to have orders, products, and I'm going to have to create this line item in between. And the reason we do that is because a relational database is unable to do a join in a many-to-many relationship. We have to break it down in 2 times one-to-many relationship. But if you think about that, a line item is not something that really makes sense. When you model with MongoDB, because an array already represents a one-to-many relationship, we can create an array of reference to our products in that case. And that will take care directly of our many-to-many relationship. So we don't have to really worry about those line item or kind of make up different entities. Now, that's a simple case. A more realistic case is, or when one of these entities describes, is that it is qualified. So I have a product that's been ordered, and also I need to keep track of the sales price and the quantity. Again, it's a many-to-many relationship, but we have additional parameters on it. This is the same thing. Now with MongoDB, we don't need to create an entity in between. We're going to have an order in which we're going to have an array of products, but instead of having just reference to our products, we're going to have sub-objects that's going to qualify. It's going to have the reference plus additional information. Okay, and finally, the last category of entity I want to talk about is the weak, or what I call child entities. And those are often objects that don't really exist by themselves, and they're not objects we really want to do something with. You'll see with the example what we have. Okay, so going back to our little example of the universal case, we list our entities, then we list the categories. What we have at this point is it may not be clear if our system is working principally with customers or orders or both, so we're going to just put a question mark on those. The other ones, product, yeah, we're making a lot of queries, going to be strong. Line items is our associative. Addresses don't make much sense by themselves. They're going to be embedded, so because they're a weak entity. So if you're modeling from scratch, and it's all fine. If you like doing an ER diagram from a relational point of view, continue doing it, identify your identities, and you're going to be fine. If you model from scratch and you're targeting MongoDB, you would probably just list those top 3 entities. The other ones are kind of, they're not really needed, especially in your model. They're just going to make things a little bit more complex. So basically what we're saying is your document model might not have as many entities as the equivalent RDBMS model, but you will need to know more about those entities. Entities are not just created equal. They have qualities, and we can do different things or should handle them a little bit differently. Okay, now we have that list. We're going to pass to our second phase of our methodology, which is going to be identifying the workload. And this is where it becomes interesting, because this is an essential phase that is done a little bit earlier than when you model for a relational database. Relational database, you tend to identify relationship, write code, and that gives you more insight when you run the queries on how you're using things. And this is not because it's MongoDB, it's just because performance is so important that we care about it earlier in the process, that we want to understand what we're going to be doing with the data. So we're going to be listing the operation. Here's an example for a use case. I'm going to have some write operation, some read operation, etc. The thing is, if you have a small project, you probably know which one it is. You may not want to go through a list of all your queries. But the key thing you're going to get, even on a big project, in my experience, is only 1 or 2 queries will dominate the other queries. So in this case, we have our read operation on the product. So people are coming to the system and they want to look at a given product. 40 million a day, that's 10 times the next query, which is only 4M. So we're going to model for that query. So going back to our bins, What we're trying to do here is a little bit of lots of read operation and some with low latency because of UI. So what we said is you should have probably objects that are a little bit bigger, co-locate information for fast read, try to pre-compute some data in our solution. Those important or main operation, I like to put a little bit more detail in it. If it's possible, identifying latency, data, lifespan, what we're going to be doing with the data, especially if it's big. Do we have to do archiving, et cetera? Do we have some concern about security, GDPR, right to be forgotten, et cetera? So going back to our list of entities, we can at that point define that, yeah, the order is a strong one because we're making a lot of queries on those orders. So we're going to change this one to strong. Okay, so doing that basically help us act when we get a modified requirement. If we didn't write anything down and the system get a load and we have issues and we look at the counters, but we don't know what we're modeling for, it's difficult to really understand what we should be doing. So understanding that you're doing your design for a certain number change, you can go back on the board and see the impact on your project. Okay, so now we know a little bit more what we're going to be doing with the system. So let's look at the next phase. We're going to establish the relationships. And when modeling from MongoDB, you have, at least I said at the beginning, two choices to model a relationship. You can reference a piece of information or you can embed it. Referencing a piece of data is putting it into another document. Okay? It's pretty much what you do with a relational database. Then you have a foreign key or pointer that gets to the other document. Usually it's about the only choice you get when you work with a relational database. But MongoDB gives you this ability to also embed the information within a parent. If it's a one-to-one relationship, let's say I only have one address, I'm a customer, it's a one-to-one relationship, and I embed. Good practice is to use a sub-object for it. In this case, we have address, make it easier for the code to just pass the address, and the rest of the code will understand what's in, no concern for the callers. If you have to embed something that's a one-to-many relationship, we use an array. So when you see an array, it's the instantiation of a one-to-many relationship. So choosing between these two options of embedding or referencing is basically the essence of data modeling in MongoDB. And that's why you're going to have possibly different solutions, and that's what we're trying to do, is to optimize for what makes sense for a project. To illustrate the concept of a relation, I like using this model here. If I had a car and I put it in a relational garage, what I will do at the end of the day is I will take the car, put the wheels on one table, put the seat on the table, put the brakes on the table. The following morning, I'm ready to go. I will reassemble the car and take it. If I put my car in a document model garage, what I will end up doing is just storing it together. And the day after, when I'm ready to take it, I take it out. Another way to look at it is when you use a relational database, you join on a read operation. As when you use MongoDB, if the information is used together, you join the information at the write operation. I get the piece of my car, I join, put them together. Read only one place, get the whole car. And this is the most important principle. Keep that in the back of your mind. This is where a lot of the other rules are derived from. Data that's used together in the application should be stored together in the database. Okay, so if it's not obvious if you should be embedding or referencing, we put together this list of questions. What you do is circle yes or no as you answer the question. If we look at this one, the relationship between our customer and our addresses, will keeping the piece of information together lead to a simpler data model in code? Yes, we circle, we go on, they go together. Do the piece of information contain similar relationship? Yes, and I go on like that, and I will answer all the questions. If it's a very good match like this one, everything falls in one column, it's pretty clear what we should be doing for that relationship. In some case, it's not. I may have answers for embedded and some other answers that prefer reference, and it's not just doing the count. Some may have a weight that's a little bit more important. But When you get in this situation, there's something else you can do. And this is where our last phase is going to come into the picture. We're going to use what we call our schema design patterns to help you. So I organized the schema design patterns, the most frequent one, in 2 different families. Obviously, we won't have time to go through all of those in this presentation, so I'll talk about a few of them, and I'll give you a reference at the end of the presentation where you can also find more information about all those patterns. The one thing I want to say about those is only use the schema design patterns if needed. The schema don't always have to be complex. When you strive for simplicity and agility, you don't have to optimize everything. MongoDB, we talk about these optimization, how to do the best model, but base MongoDB, even if you make mistake, it is still super performant and will get you good performance. Okay, so one concept that's related to a few design schema pattern is the data duplication. Again, relational database made it a point earlier in the history that it was to be avoided. Okay, that's the term normal form. But interesting enough, Cod in his paper, if you read it correctly, pay attention, it does suggest that we could use denormalization to the detriment of spending more on storage to get better performance. So it was already in his paper. What is really interesting with data duplication is even if it's frowned upon, it's pervasive in the organizations. It may not be found in a given database. You may try to normalize your database to avoid it, but I'm sure many of you have many databases in the organization where you have information about your customer, and this is a kind of data duplication anyway. Data duplication is related to staleness. So the real question is how much staleness can you tolerate between a piece of data, the master and its copy? So I like to group data duplication into 4 different sections. The first one is what I call immutable data, data that never change. An example, maybe the date at which a customer is acquired, a log entry. As you collect those, you put it in your information. I love this type of data when I do a review because then I can point a customer to it and they can safely make copies of that without any concern to get better performance at read time. The second one is temporal. It refers with something that changes with time. Think maybe a slow changing dimension. But the characteristic is the value at the time that you use it should not change as a future value. Here's an example. If you have a customer who passes an order, and I need to make a link that this customer order was sent at that place, and I point to the customer, and then the customer move, I don't want my order to have this information change. I want to keep the address at which I ship the information. So think about it, copying the address of the customer at the given time inside the order is data duplication, but it's really the right thing to do in this case. The third one is data that's very sensitive to staleness. If I update this piece of information, this one has to be updated at the same time. MongoDB support transactions the same way relational database do it. We also support it in a sharded cluster, which is pretty complex, but it's very similar. So if you have this type of data that has to always have the latest value, if I change that, everyone who depends on it's a many-to-many relationship. I want to have this value being updated on all my reference. Go ahead, and use a transaction for that. You also may have a data that is sensitive to staleness, but can still afford a little bit of maybe a few seconds of staleness. And for that, you can use a trigger in MongoDB. An example will be if I update the price of a product, well, I could listen to a trigger where price gets changed, and I can see if there's active carts, and then go change the price in the carts. Finally, the last one is not be very sensitive to staleness, very similar to the previous one, except that here we say, hey, it's going to be more than a few milliseconds or a second. We can go much further. In this case, what you can do is you can schedule at the appropriate time the updates based on the accepted staleness. If I was going to count the number of reviews on the project, that is probably the staleness on that being like an hour or a day is probably acceptable. So I can just have a job that count the number of reviews and update it in the documents once in a while in the day. So there's obviously this trade-off with Staleness. You know, don't go and say, Daniel told me like it's okay, I should duplicate all the data. It's basically, you're going to get some disadvantage, you're going to get advantage, and you have to look at what makes sense for your project. In some cases, obviously, immutable data is very easy. But the rest, if you're going to pay much less hardware by doing some data duplication, but the case that the city name change, you have to go and change it in a few places, it's still pretty worth it. Okay, so we'll talk about a few of these patterns. The first one I want to talk about is the extended reference pattern, and I'm going back to the case where we're not sure if we're going to embed or reference, okay? So what this pattern does is basically copy the fields from one of the entity into the other one to avoid having to do joins. So we're going to put some information so the main queries can run without doing the joins, but we're not copying all the information, especially the one that may be problematic. Here, that's going to talk a little bit more to it with this example. If I have, for example, an order document and I have my customer, well, we do have that many-to-many relationship. If I copy the customer inside, I'm going to be creating that duplication that may be annoying for me because I don't want to go and update all the orders, for example. Maybe it's too big. If I leave it as a reference, well, I have a foreign key and I have to join every time. Well, the solution is in between, in this case, using the extended reference pattern. What I can do is copy some of the information of the customer. And if you look at that here, we talk about the address, that yeah, makes more sense to copy. But the customer ID and the name also, in this case, are not going to change. Okay? So I'm putting enough information that if someone is pulling the order and is looking if what the order is about, we'll have enough information without having to do joins. The second one, the computed pattern, and as a matter of fact, this one plus the previous one, extended reference pattern and computed pattern, are by far the two patterns I use the most when I do design reviews with the customer. So if there are two that you should like understand and kind of remember to apply when it makes sense, these are the two. So this pattern here stores results of computation directly in the concerned document. The computation are generally done at right time or through a job periodically. So this pattern is useful when you have a high read-to-write ratio. Because if I have, for example, reviews on my project, on my product, and I get 10 new reviews per day, but I get 1 million views, well, when I get this new review, I can do something in my product document that I won't have to recalculate. Number of reviews, average ratings, whatever. So it's going to be much more effective than recalculating those values 1 million times, because I'm calculating the same values in average 100,000 times per view, no? So, and this is not something that you cannot do with a relational database. You could pre-compute things. The only thing is the document model is so much more adapted for that, because it's not just values that you can put into the entity, but you can also put arrays. You can put much richer stuff, and you'll see it here. For example, if we have a product document and I want to count the number of reviews, the average rating, but I may have also the views per month. I can have an array. And the key thing is really to put it in the document you are already reading, so you don't have an additional read to get the information. Okay, so one thing I forgot to mention, I think, is when we were looking at the page, the product page, if someone had the idea that we should also keep track of the number of page view of all the products that our customers are looking at, that was 40 million a day, I would have generated 40 million additional write operation, okay? That is a lot for counters. If this is important for your business and you have the money for it, go for it. But usually, and we've seen that in practice, that's not the case. You're not ready to like double the size of your cluster just to keep track of counters. So this one is a pretty cool pattern in order to avoid that. So what we're going to rely on is the fact that we don't really need exact numbers. That's really important. And the way we're going to do it is we're going to increase the payload. We're going to do less operation, but increase the payload. Here's an example. If I was going to record all the write operation, every time I have an event, I do an increment 1 on my counter, store the update in the database. What if 1 out of 10, I do an increment by 10. So I just divided the number of operations on my cluster, at least for that, by 10. You could imagine 100, you could imagine whatever you want. And the way we would do it in this case here is just give me a random number, 0 to 9. If it's 0, I increment by 10. If it's another number, I just don't increment. Okay? So the number I'm going to get will be good enough what I'm trying to accomplish here. The next pattern is the archive pattern. This is a very useful pattern for industry that have like data retention, regulation, think financial, pharmaceutical application. The goal here is to lower the cost of keeping the data that you're not using often. So what we're going to do is going to put the data in a structure that is cheaper. If you're using Atlas Online Archive, that's exactly what we're doing. If you're not running on Atlas, you could put it on the cluster that's under provision, and that also would be a way to also store some, to save some money. Or if you have a way to manage S3 storage, you can put it there. So it's pretty simple if you think about it. But the key thing about the archive pattern is this is extremely difficult with a relational database. If I want to archive, for example, an order in a relational database, I would have to archive a bunch of little pieces of information that come from my customer, my order, an address, all at the same time in a certain way that I can like join them back in the future. And what if my schema change? With the document model, it's extremely simple. You already have a document, in this case the order, that's already pre-joined with everything that's interesting. If you take that document, put it in an archive, even if your schema change a little bit, you can still access this document through a query. And this document can even make sense in an editor. You can get the document, bring it in an editor, and make sense out of it because it's already pre-joined. So it's one of my favorite patterns. And it came pretty late in the description of the pattern because I just didn't think of it at the beginning. But working with a lot of banks who all have these requirements of keeping the data from 10 years, just realized this is what they need to do. And it's so easy with MongoDB. As a matter of fact, I consider it so important that if I had an application for which data retention of 10 years, for example, was one of my main requirements, that could be like just the unique reason for which I'll be using MongoDB because of the simplicity of being able to read these documents in the future. And finally, the last pattern I want to talk about, which is the one that kind of makes a lot of things possible, is the schema versioning pattern. So what we're going to do here is allow tracking modification on your schema, be able to make easy modification. Well, the first principle here is like, the question is not if you're going to have like changes, you will add them. It's more when you're going to have to do changes on your schema. And two types of modification is, for example, the field modification. That's pretty easy. Relational database handle that pretty easily. Alter table, do whatever you want. But the case that's a little bit more complicated is a relationship modification. I go from a one-to-one to one-to-many, for example, and this is what we're going to do here. Let's say that we have customers, and we have a home phone number and a work phone number for them, old style. And those are one-to-one relationship with a customer, because they're columns. And then we want to go to that version 2 of our schema where we want like something a little bit more modern. We want to be able to track other mode of communication, WhatsApp, for example. So we're going to bring that information somewhere else. We're going to create this communication table. We have a relation one-to-many, so we change the type of relationship. If I'm trying to do that with a relational database, well, on Friday night, maybe I have version 1, and I'm going to bring the system down. I'm going to extract some data, create a new table, migrate, and then have my 2 tables on Monday, change my application, etc. Everything is good, but I did get downtime. If we try to do that same modification with MongoDB, well, we want to go from, let's say, this version 1 to version 2, where that one-to-many relationship will be an arrays. We could have had 2 collection. It would be exactly the same. The key thing here would be to version the document. When you work with a relational database, you do have like one version number for the whole database. With MongoDB, because of polymorphism, you can have that version number on every single document. So I can take the time it takes, 5 minutes, an hour, a week, to slowly change my documents. So I can have, for example, on Friday night, all my documents in version 1. That's what I want on Monday. I want all the documents in version 2. Well, I can go one document by one and update them. Not everything has to be done together. As long as the application is able to read both shapes of the document, I'm golden. Things are going to work. Now, I may have some queries that are a little bit more difficult to write. I don't want to change them, etc. So that's why I'm saying that you may have like a little degradation here, so it can take care of some queries. Other ones, let's not run them, for example, over that weekend. OK, so applying all the rules that we've seen and our schema design pattern, we would get something that looks a little bit like that. We'd have like 3 main entities. You can see some of the entities that have been embedded. You can see also some values that have been calculated through the computed pattern, etc. And at the bottom, we do have our reference data, the lookup data. So the schema design patterns are really the secret sauce to make your application perform faster. Again, use the one that makes sense for application in order to satisfy your performance requirement. Okay, and finally, let's quickly talk about schema validation. It's a feature that a lot of people don't know about or they're not using. We tend to think that MongoDB, you can put anything in it. It doesn't matter, no structure, I don't define a schema. That's true, but it doesn't have to be like that. As a matter of fact, for a lot of customers, what we call one of the anti-pattern, MongoDB does have a feature called schema validation. And it's pretty flexible. You can decide exactly what you're going to check. You don't have to check the whole document. You can check a certain list of fields. The other one's going to be free-form. There's a payload that comes from a system from which you import. You just want to control at least some part of the structure. You want to control everything. It's also fine. So when you create a table in a relational database, you get to specify the type. You don't have much choice on that. And you can also add some checks on consistency. Some fields may start with no B, P. They have like a range of values. Well, that exact list of checks that we have here can be implemented in MongoDB with that. So we rely on JSON schema, which is a standard out there. We extended it to support the BSON type because we're not really a JSON document. We're a BSON database. And you would structure your checks like that. You would list the required properties. For example, for each of these properties, you can say the type that's expected and range of values, expected type of values with regular expression. And then you attach this validator at the end. And we just talked about the schema validation, not schema validation, the schema versioning pattern, which you could have 2 shapes at a given time. How does it work? JSON schema has an operator that's called one-off. So you can define your 2 schema, one for version 1, one for version 2, and ensure that all the documents in your database at a given time have either of these 2 forms. The other thing with schema validation, it is, again, optional, but once you attach it, you also have the option to say if a document doesn't respect that on insertion of update, I'm going to reject the document. But you can also say, just warn me about it in a log somewhere. So then you can go back to your customer, the provider of that data, and say, we changed the schema. You're supposed to send us this field. I'll fix your stuff, but in the future, really, it has to apply to, it has to obey to our rules here. So in conclusion, one of the things I want to bring back is really, we're in need for modern modeling. Things have changed from the 70s, and this is what we want to do with our methodology here. It's very simple methodology, 4-phase. And again, the main principle when you apply the methodology, when you decide what you're going to be on that crucial question of embedding versus referencing, is data that's used together in the application should be stored together in the database. And finally, those schema design patterns, there's a secret sauce, to make your application run faster. To learn more, I had the occasion to co-author a book with other authors 2 years ago. That's the probably most up-to-date reference on all the schema design patterns. We do these events. You guys are here, great. We also have the workshop. There's some happening there, but we also have days about just workshop, coming to some cities, hopefully yours. And then we do the design reviews, as I said, one-on-one design reviews. So if you're a customer of ours, and you want to have a design review, reach to your rep, and it's something that we can organize. The design reviews are a great tool to learn at the same time. It's not just we're going to help you on your schema, but we're going to try to make you understand why we're saying certain things. So when you go back in your office and things change, or you have a new project, you'll understand how to do it. At the end, it's not rocket science. You've done a few, you'll become pretty good at it. And then finally, the best place if you want to learn more about anything MongoDB is really the MongoDB University. We do have a booth out there. You can stop. I think it's on the next floor. They're the one who organize all the badges. In the earliest time, we had these very big certification. We have a ton of courses. And this year, we try to create those little badges, which is really like a unit of knowledge on something. For example, there's one that I really like about indexes. When I do reviews with customers, I realize that often those customers have misknowledge on how to create a compound index and misknowledge about how to read and explain plans. So there is a little badge that covers these two very important concepts. So what we're going to do today is do one of those badges, is this one. Relational to document model. When I say what we're going to do today, I'm going to give you the URL. It still takes about 10-15 minutes. Take a copy, do it on your time, or you can always go back to the URL. I know some people are going to take the picture. If you don't intend to do it right now, you can also note the URL over, down there, which is mdb.link, local-New York City /rel2doc. Give you a few minutes, a few seconds to do that.
Daniel?
That's nothing. Thank you everyone.